Here, yesterday I given as a homework. Anybody can able to tell the answer. What is the d value according to the first theory, according to second theory? Anybody is ready to tell the answer? Otherwise, I will start this explanation. Okay, see here. A solid circular shaft is subjected to bending moment. So see here, this type of problems today I am going to discuss. Um, the shaft is subjecting to the combination of bending and torsion. Okay. So see here, based on the statement given in the question, based on the statement is given in the question. Okay. Okay. Based on given statement in the question, bending moment is 3000 Newton meter, torque is 10,000, and shaft is made of some material type is given 45 C8, and having the ultimate tensile stress 700 megapascal, and ultimate shear stress 500 megapascal. Okay, in fact, factor of safety given and asking to calculate determine the shaft diameter. Nothing but designing the shaft here. So designing the shaft is nothing but calculating the safe dimensions for the machine elements. Okay, what machine element we are designing here? Shaft. Okay. Now for these two equations we are using, because when the shaft is subjected to the combination of bending and torsion, these two equations we need to use. That is the rule. Okay. So what is the equation? Equivalent bending moment, m suffix small e equal 1 by 2 m plus square root of m square plus t square. This equivalent bending moment is nothing but pi by 32 into sigma b into dq. Okay, in this d value we need to calculate, and according to the shear stress theory, equivalent torque T equal square root of m square plus t square. This derivation already you have seen in the previous classes. Okay, this equivalent torque T is nothing but pi by 16 into sigma s into dq. Okay, now in this bending moment is given in the question as 3, and torque value is given 10,000 Newton meter. Okay, and additional thing you need to calculate is sigma b is not given, sigma s is not given. Here shear stress is given. What type of shear stress? Ultimate shear stress is given. Here ultimate tensile stress is given. Okay, so we need to calculate the first this sigma b value and this sigma s value. Okay, now first I am calculating the sigma b value. So here one relation is given from the factor of safety, that is factor of safety is what is the definition of factor of safety? It is the ratio of maximum stress to working stress, general meaning. Okay, the general meaning is factor of safety is equal to maximum stress by minimum working stress. Okay, so this one also known as it is a ratio of ultimate tensile stress to, it is ratio of ultimate tensile stress to normal working stress. Now for this case, I am calculating bending stress. So instead of writing working stress, I am calculating as a working stress for bending. Okay. Now through this relation, what is bending stress? Through this relation, what is bending stress? The bending stress is ultimate value is given as 700 megapascal. Ultimate value is given as 700 megapascal. Okay, and factor of safety how much given? 6. 700 by 6 how much? What is the bending value? Bending stress value 700 by 6. Tell the answer. 700 by 6.
116.7.
Very good. 116.7. Similarly, tell me this value also by using this factor of safety relation, megapascal. Okay. Megapascal. Now tell me that this sigma s value with same equation. Factor of safety is equal to ultimate shear stress. Instead of writing tensile, ultimate shear stress by this is the working shear stress. This is the working shear stress. Now at this time, what is the shear stress here? What is the shear stress here? Shear stress is 500 by 6. Shear stress is 500 by 6. 500 by 6. What is the value here? 500 by 6 means some 84, 83, okay. 83 megapascal. Okay, 83 megapascal. So these two value we calculated. Substitute here. One by one I am substituting. According to the first theory, what is that? Pi by 32 as it is. Pi by 32 equal pi by 32 equal into sigma b as a 116.7, sigma b as a 116.7, and this is a d cube as it is, that is d value only we need to calculate, and 1 by 2, okay, 1 by 2. Bending moment, how much given? M value here in the question, 3000 Newton meter given. So substitute as it is 3000. Okay, substitute as it is 3000 plus square root of 3000 square plus 3000 square plus 10,000 square. Square. Okay. Now tell me the value of D. Tell me the value of D. The D value you will get in terms of mm. Tell me the D value in terms of mm. Make it fast. Tell me the D value in terms of mm. Everything I written on the screen. Only you need to submit the values in Calci and tell me the answer. Write the answer in chat box. I request to all students, write the answers in a chat box. What is the D value? Make it fast.
Sir,
Yeah, tell me, Babu. 6.45. Somebody.
it is 10,000 or 1,000, sir?
This is the 10,000 given in the question.
Okay, sir.
Somebody is given the answer. Rule number 6.45, not 6.45. 8.3, not 8.3. Make a calculation properly, not 8.3. So you are getting the values in meters. Tell me the mm. 8.3 is the correct one. Tell me the in mm. Tell me in mm. Rule number 70 has given the answer 8.3, but it is in meter. Tell me the 800 mm. 83.7. 83. Okay. Now tell me the answer according to the second theory, this principal shear stress theory. Tell me the value of D, because already I calculated the sigma s value. Okay, let it be sigma s value I calculated, and m value is given in the question, t value is given in the question. Only the thing is you need to calculate the D value. Okay. Now tell me the D value according to this theory. According to this theory, pi by 16 S value got as a 83 megapascal. D value you need to calculate, and square root of 3000 square plus 10,000 square. Yes, please mute yourself. Now tell me the D value according to the second theory. What is the D value? Tell me the D value in mm. Tell me the D value in mm. 8620. 86 mm. Very good. Okay, this is the according to the shear stress theory. Okay, now see here, while solving the problem, see the what properties of the material is given in the question properly, because here directly you are going to substitute. Here the statement is given ultimate tensile strength. Ultimate tensile strength is given. If you not read properly, what you will do, directly you are going to substitute the 700 here. If you read improperly, what you will do, 500 you are going to substitute here. So at this time what happened, the answer will go into wrong here. Okay, so read the question properly. What type of material properties is given in the question? What type of material property is given in the question? You need to check properly. And while solving the problem in your calci, whatever the values you are substituting, that make sure that they're correct. Okay, now this is the second question according to the combination of bending and torsion. Okay, now a shaft is, wait, a shaft supported at the ends in a ball bearings carries a straight tooth spur gear at its midspan of, and is transmitting the 7.5 kilowatts at 300 rpm. Okay, so one shaft is there. Yes,
Previous problem doubt, sir.
previous problem. Okay, ask Babu.
Sir, how will get 83.7 or 8.37, sir?
83, suppose it 83, 8.37, that is in meters. 8.378 some lengthy value is there. Okay,
Sir.
that you need to convert, in a mm, because you are substituting the values here directly. See here, you are substituting the 3000 here. 3000 is given Newton meter, 10,000 is given in the Newton meter. Okay, here 10,000 is given in Newton meter. So that's the reason your answer will come in terms of meter. Okay, that meter you need to convert into mm. That meter you need to convert into mm. Okay, because in design of machine elements or machine design in other subject, all values are should be in mm only. Remember this blindly. All values should be in mm.
Sir, then D is equal to 86. How will it?
Which one? Here also, after getting the meter, directly somebody is telling the answer in terms of mm, because I'm asking, tell me the answer in mm. Here also in
Uh,
the second answer also you are getting the values in terms of meter, but I am asking tell the answer in terms of mm. So that's the reason you people what you are doing, you are converting and telling the answers.
okay, sir.
Okay. Now a shaft is one shaft is there, and the shaft is supported at the ends of the ball bearing. Shaft is there, so I'm drawing here. One shaft is there. Okay, one shaft is there and supported. The shaft is supporting in the ends of the ball bearing. So I'm drawing the ball bearing here. I'm drawing the ball bearing here. This representation here, making the square box and writing the cross mark that represents the bearings. Okay, that is a conventional representation of the bearing. Okay, like this. This representation is nothing but conventional representation of the bearing. The question is given shaft
ये
is support.
उठा गला आपण वैसे
Yes.
सज्जा हेड हाँ 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 शिवानी
Yes, mute yourself. Now see here, the shaft is supported in the two bearings, ball bearings, and carrying the straight tooth spur gear. One gear is it is carrying, means gear is mounting on the shaft. So how it is going to mounting? It is at the mid span, exactly mid of the shaft. The gear is going to locating. So here I am drawing the gear. One gear is going to mounted like this. One gear is going to mounted like this. That what type of gear? This is a spur gear having the straight teeth. Spur gear is having the straight teeth. So I am drawing the straight teeth here. Okay, straight teeth, mid span, and transmitting the 7.5 kilowatts of power and running at a 300 rpm. The pitch circle diameter of the gear is 150 mm. So this pitch circle diameter of this gear is given as 150 mm, and the distance between the center line of the bearing and gear is 100 mm each. It means from the center of the bearing to its center is 100. From this side, it is also 100. From the center of the bearing, it is also 100. It is also 100 mm each. If the shaft is made of steel, material type is given steel, and allowable shear stress. See here, allowable shear stress. Directly the shear stress value is given in the question. 45 megapascal. Determine the diameter of the shaft. Determine the diameter of the shaft. Now here show in the sketch how the gear will going to mounted on the shaft. That is we have shown here on the screen, and also indicate the ends of the where the bearings will going to mounted. So these the bearings I have shown here. Okay. So for the diagram, some situations diagram for the diagram also you have the marks. Okay, so diagram representation of the diagram also very important in some situations like this, particularly when the question is mentioned. Also indicate the ends where the bearings will going to mounted, and the pressure angle may be taken as a 20 degrees. Okay, now what is asking to calculate diameter of the shaft. So first we need to analyze what the given problem belongs to which category. This is the first question while you are starting the solving the what is the first question here. The given question is belongs to which category. We have broadly, as I said earlier, two categories based on the strength, based on the rigidity. Again, strength, four different categories are there: purely torsion, purely bending, combination of torsion and bending. Okay, additional axial load. Okay, these four categories are there. Among these four categories, the given problem belongs to which one? That is the first question. So see the diagram. Because of the gear is mounting here, the load is acting transversely to the axis of the shaft, isn't it? Because of the mounted gear is going to mounted on the shaft, the load is acting transversely. And next thing is because the gear is transmitting the power of 7.5 kilowatts, it is transmitting the power 7.5 kilowatts. Because of that reason, the shaft is going to subjected to torque. The shaft is going to subjected to torque. Because of this, the shaft is going to subjected to bending moment. Okay, so here combination of torque and bending moment, it is subjecting to combination of torque and bending moment. Okay, so at this time, this type of problem is going to solve with the help of combination of torque and bending moment. Okay, so with the help of combination of bending moment and torque, what are the relations are there? Again, the next question. There are two relations according to maximum principal stress theory, another one according to the shear stress theory. So if the particularly question is mentioned, solve this problem particularly with the help of shear stress theory, then you have to solve the problem according to the asking the question. If the question is not asking particularly solve with this theory, particularly solve with this theory, like that, at that time you need to calculate the both the theories. Okay, so first according to the shear stress theory I am calculating. First I will calculate the according to the shear stress theory. You people solve these problems, this same problem with the help of maximum principal stress theory. First theory, okay. I am using the according to second theory. So what is the second theory? The second theory is equivalent torque TE equal, what is the equation? M square plus torque square, M square plus torque square. With this equation we can solve the problem. Okay, so here M is the bending moment. See, the bending moment is given in the question. Is there any data appearing bending moment? It is not appearing in the question, that we need to solve additionally. See, the torque value is given in the question. Torque value also not given in the question. Okay, so M value and additionally this T value, both we need to calculate. Again, from the TE means what? Equivalent torque, that is pi by 16, that is TE means I am writing pi by 16 into sigma s into d cube into d cube. So here sigma s is the allowable shear stress. Sigma s is the allowable shear stress that is given in the question here. Allowable shear stress, that is 45 megapascal is given in the question, and the D only we need to calculate, and we don't know the M value, we don't know the T value. So here how many unknown parameters here? D is unknown parameter, T is unknown parameter, M is a unknown parameter. So more than one unknown parameter is there, we can't solve the problem, isn't it? Now one by one we need to calculate. So first power equation we know. What is power? Power P equal 2 pi nt by 60. This equation already you know, 2 pi nt by 60. So with this relation you can get the answer torque. With this relation you can get the answer torque value. So how much torque value here? Tell me the answer. Power is given 7.5 into 10 cube. Substitute power I am writing here 7.5 into 10 cube into 60 into 60 by 2 pi. N value how much given in the question? 300. N value is 300. Now tell me the torque value. Tell me the torque value. Torque value 238.7 Newton meter. Very good. Roll numbers is given 238. 30 238.7 Newton meter. Now torque value we calculated. Now we need the bending moment. Okay. So to calculate the bending moment, see here I am drawing additional diagram here. The front view of this system, the front view of this gear I am drawing here. See, this is the gear. Okay, this is the gear. So while transmitting the power from the gear, suppose gear is rotating in a clockwise direction. Okay, this analysis is very important. Again, this analysis you are going to face in the machine design subject in design of gears. Okay, I am additionally explaining here. Suppose this gear is rotating in a clockwise direction. This is the front view of this gear. Okay, this is the tangential load WT. This is the tangential load WT, and because another gear is attached to with this gear, another gear is attached with this gear. So because when the both gears are in a meshing, then only the power is going to transmit. Because of that reason, what happened? Because of attaching the another gear here, it is subjected to radial load. It is subjected to radial load. Finally, what happens? From this side it is tangential load acting, from this side radial load acting. Because of this reason, what happening here? One resultant load is going to generate here. One resultant load is going to generate here, that is known as here normal load. One resultant load is going to generate here. Because of what the reason? One tangential load is acting here, one radial load is acting here. Tangential load because power, and radial load because another gear is going to attaching here, meshing here. Because of these two loads, the resultant load is going to acting. Okay, that is known as a normal load. Because of this resultant load, so here the direction of resultant load, how I shown in this direction. So in which direction the resultant load is acting, in that direction the gear is going to start rotation. Okay, so subjected to the alpha, it is subjected to the alpha because T is having the nothing but pressure angle. This is known as a pressure angle. Okay, this is alpha. Now here this WR load I am writing here, make it complete triangle. WR load, instead of placing here, I am replacing here with here, WR. Okay, to make it complete triangle. Okay, now what we require? We know we need to calculate the total load acting on the bearing. Okay, what is the total load acting on the gear or bearing here? That is normal load. Total load is acting on the gear is nothing but normal load. Okay, that normal load is nothing but whatever the load acting on the shaft. Okay, whatever the normal load is generating on the gear, that is nothing but whatever the load acting on the shaft. Okay, so this load acting on the shaft we need to calculate. So first is here how to calculate the load acting on the shaft is normal load. So before that, torque equal to force into perpendicular distance. Perpendicular distance is nothing but d by 2. I am writing d by 2. Okay, so this torque, this is the torque, force into perpendicular distance. Okay, so this is the torque I am applying here. Torque is equal to force into perpendicular distance. What type of force here? Tangential force. So I am writing the tangential force here. Okay, so tangential force into d by 2. D by 2 is nothing but its radius. Okay, just now we calculated the torque from the power relation. Just now you calculated the torque from the power relation, and with this relation you are going to calculate the ft value, nothing but wt value. Okay, so tell me that ft value. D is nothing but 3182. Rule number 2 is given 3182. Very good. What is D value? D value is given in the question 150 mm. Pitch circle diameter is given in the question, capital D. Okay. So how much this one? Somebody answered rule number 2, 3182. 3182. What is the units? Newton. Very good. Okay. This much of tangential load is acting on the gear. Now, what we require? We require the normal load. Normal load is nothing but resultant load acting on the gear, nothing but it is acting on the shaft. Okay. So normal load we require. So normal load, to calculate normal load, see the triangle here. This we know the WT. This is known as a WN, and alpha is given here 20 degrees. Alpha is given here pressure angle 20 degrees. Okay. Now anybody tell the relation between the WN and WT with this triangle? With this triangle? Anybody tell the answer? With this triangle, tell me the relation between the WT and WN. So I am writing here. The relation between WT and WN is cos alpha equal what is cos alpha from the above? Cos alpha is nothing but WT by WN. WT by WN. WT by WN. Tangential load by normal load. Normal load. Now, what is the normal load here? Normal load is, just now you calculated the WT, that is 3182 by cos alpha. Cos alpha how much given? Cos 20. Cos 20. Okay. Tell me the value of normal load acting on the gear. 3386. Very good. 3386, not 3.86, 3386. 3386 newtons. Very good. Okay. Normal load is acting on the shaft. So the normal load is nothing but whatever the load is acting on the shaft. Okay. Because of this load, what happening here? Shaft is going to subjected to bending moment. Okay. Now observe the diagram here. Observe the diagram. This diagram is having symmetrical diagram. Symmetrical means from the center of the gear to the center of the bearing, it is 100 mm. From this side, center of the gear to center of the bearing, it is 100 mm. It means this is the symmetrical one. This is the symmetrical one. Otherwise, this is the supports. This is the support. Consider this is the simply supported beam. This is a simply supported beam and acting the point load at midspan of the beam. Now what? Tell me the bending moment equation for this one. Anybody? Bending moment. This is a simply supported beam. Okay, and mid load of the beam, it is subjected to at mid point load. So for this, what is the bending moment? Very good. WL by 4. Bending moment is WL by 4. WL by 4. W value just now you calculated as 3386. 3386. L value how much in the question? Total length of the shaft 200. 100 one side, 100 one side means total length is 200 mm. 200 mm is given in the diagram by 4. So what is the bending moment here? Tell me the bending moment value. Tell me the bending moment. 3386.
16.
Somebody given the answer.
169300.
Very good. Bending moment value is given 1693
169300.
double zero. So 1693 double zero. What is the units? Newton mm. Okay, Newton mm. Now convert this Newton mm into Newton meter, because torque value is here we calculated in terms of Newton meter. Torque value we calculated here in terms of Newton meter. So that is the reason convert this into Newton meter. Newton meter. What is that? Newton meter 169.4. 169.3 Newton meter. Okay. Now m value we calculated and t value we calculated here. Substitute in this equation. Substitute in this equation. Sigma s value is given in the question 45 megapascal. Now tell me the d value. So I'm substituting here. Tell me the answer. M value just now we calculated first 5 by 16. 5 by 16. 45 megapascal is given in the question. Sigma s value. And d cube, that only we need to calculate, equal square root of 169.3 square plus torque. How much we got previously? 238. 238.7. 238.7 square. Okay. Now tell me the value of D. Answer D 3.2. Answer is 3.2. Very good. Your answer you got in terms of meter, that is 3.2 meter. Now tell me the answer in terms of mm. Tell me the answer in terms of mm. That is 32. Yeah. You people, just I calculated the D value according to the maximum principal shear stress theory. Okay, you people calculate it this answer as a homework according to the maximum principal stress theory, first theory. Okay, calculate the D value. Now tell me the answer in next class. Okay, 33.12, that is in meters, convert into mm. Very good. Okay. Now see the next problem. Any doubt regarding this in this problem? Regarding this problem, any doubts you have, you can ask. I calculated the answer according to the second theory, whatever the formula is appearing on your screen. I am telling that you people solve the answer according to the first theory, maximum principal stress theory. Okay. Everything is calculated, whatever the requirements. Okay, only the substitution of the formula is remaining. Now see the next one. A shaft of mild steel is required to transmit the 100 kilowatts of power, 100 kilowatts of power running at 300 rpm, 300 rpm, and supported length of the shaft is 3 meter, means total length of the shaft is given as 3 meters, carries it carrying the two pulleys each, how weight is 1500. It is carrying the two pulleys of each one is the 1500 newtons supported at the from the ends respectively. So first I am going to draw the diagram. So this is the shaft, this is the shaft, okay. Now the shaft is having the length how much? 3 meters length. The shaft is having the 3-meter length, and it carrying the two pulleys. It carrying the two pulleys of weight 1500 each and 1 meters from the each end. So from this end, one pulley is having the here. From this end, another pulley is here. Another pulley is here. Okay. Another pulley is here. Okay. Now how much distance? This is the one and this is the 1 meter. This is the 1 meter and this is the 1 meter. And each one is having the weight of 1500 newtons. Each one is having the weight of 1500 newtons. This is also 1500 newtons. 1500 newtons. Okay. And assuming the safe values for the stress, here stress value is not given. The question is telling assuming, means ourselves only we need to assume the safe stress values, determine the diameter of the shaft. Determine the diameter of the shaft. So how much is the diameter of the shaft? Okay, this d value we need to calculate. So to calculate d value, first what is the thing? First we need to check whether it is means the given question belongs to which category. Means there are 4 or 6 categories based on the strength, based on the rigidity. In strength 4 and rigidity 2, total 6 categories are there. Okay, among the 6 categories, the given question belongs to which one? So here see the diagram, observe the diagram. On this shaft, 2 pulleys are mounting. Okay, because of the pulleys are mounting, the shaft is subjected to the bending. Okay, and the shaft is transmitting the power that is given 100 kilowatts power. So because of that reason it is subjecting to torque. Because of the these pulleys it is subjecting to the bending. Okay, so see here torque and as well as bending, it means this is the problem belongs to the combination of torque and bending. Now again the question is third category we selected. According to the third category, the given question, which equation is suitable? Again in this question, which equation we need to use, that is not given. Means particularly solve this answer according to the shear stress theory. Otherwise particularly solve this answer according to the maximum principal stress theory. Like that the question is not mentioned. So at that time we need to calculate the both values according to the both theories we need to calculate. So here according to the I am calculating the according to the first theory. Here I am calculating according to the first theory. Equivalent bending moment equal 1 by 2 m plus bending moment plus square root of m square plus t square. So in this case I am going to solve the answer according to the first theory. I am asking to you people this same question solve the according to the second theory, maximum shear stress theory, what we practiced just now in previous problem. Okay, now in this bending given in, so we need to calculate torque value is given, it is also not given in the question, that we need to calculate separately. Again ME means what? ME is nothing but equivalent bending moment. Equivalent bending moment means pi by 32 sigma b pi by 32 sigma b into dq. So in this, sigma b value is given. See in the question, sigma b value is not given in the question. That we need to assume. The question is itself mentioning that assuming the safe values of stresses. Okay, so safe value of stresses, I am assuming sigma b as a 100 megapascal. I am assuming sigma b as a 100 megapascal. 100 megapascal. 100 megapascal I am assuming. Okay, now one by one I am calculating torque value. First, torque value we can get with the help of power equation. Power P equal 2 pi nt by 60. Power is 2 pi n t by 60. So T value how much? Torque value how much with this relation? T value is how much? 100 kilowatts. It means 100 into 10 cube. 100 into 10 cube into 60 into 60 by 2 pi n. 2 pi n value how much given? 2 pi n value is given as 300 rpm. So what is the T value? Torque value how much? It first. Tell me the T value. Today the attendance is very less, Babu. What is the reason? Only 73 people have presented. Yesterday it was 90. About 90 students were present. Today is a okay. 70 is given answer 3183. Okay. What is the reason? Listen, Babu. If you are absent, you are not going to understand the whatever the concept I am telling here, because design of machine elements